How to build a Lulzbot TAS6 3D printer and an enclosure. All that and more this time on Hak5. Hello everybody and welcome to this episode of Hak5. My name is Shannon Morse.
I'm David Randolph.
And this is your weekly dose of Technolust. As you can see, I am joined yet again by my friend David Randolph over at printedsolid.com. Super excited to have you back again.
Well, thank you. It's time to come back.
Yeah, thank you so much for joining me again. So I'm really excited about today because we're going to build this baby right here, which is super exciting. But first, I do have a couple of announcements to make. The 30-day security challenge that I was doing over at techthing.com. I should be on vacation right now as long as I actually made it to Japan. But you can check out that 30-day security challenge. I'm so proud of it. YouTube.com/techthing for that. We're also continuing our Hak5 contest. That's over at hak5.org/contest. If you haven't checked it out yet, please do so. And last off, Metasploit Minute is going to be coming back, which I'm super excited about. So we're going to have Mubix in town. That's over at youtube.com/hak5. If you aren't subscribed already, definitely check it out. So this week we are building the TAS6. So first off, we should probably get a little bit of history out of the way. So what is the TAS6?
Well, the TAS6 is the current printer that's being sold by Lulzbot, a company out of Colorado. And it's completely open source, and they've had the TAS6, the 5, the 4, the 3, the 2, and then they had the A01.
Okay.
So they've had quite a few printers. This is their most current iteration of that.
So this is the Wi-Fi Pineapple Nano of the 3D printers from Lulzbot.
But as you can tell by the box, it's definitely not Nano.
No, it's not. But they do have a mini one too, right?
They do have a mini one,
Okay,
ironically called the Mini.
Oh, surprise, surprise. So how much does this one cost for everybody out there?
Retail's $2,500 on these.
Okay, wow, that's a little expensive. I feel like I should not break it. But we're actually going to be talking to Ben from Lulzbot tomorrow in studio on the show. So we're going to ask him all about like running a company that's fully open source and everything. I'm super excited about that episode as well. But I was really interested in building another 3D printer on the show because the last time I actually got one in hand was 4 or 5 years ago, and it was the printer bot. It was the kit. So you had to build it all yourself. It was made out of wood, and you already told us about like wooden 3D printers in their previous episode. So,
and they've definitely evolved since then.
Yeah, it's definitely evolved. So if you want to check out those previous ones I did about the printer bot, you can check those over at youtube.com/hak5. But today, we are going to build one that is a lot more friendly for consumers, and along the way, David is going to be giving us some information about the anatomy of a 3D printer because I feel like it's so important to understand the theory behind it as you build it. So you understand all those pieces and why they are important.
Exactly, and we'll talk about the structure, we'll talk about some of the key components in them, and kind of what to look for in 3D printers when you're getting one.
Totally. All right, well, let's get back into it. What do you think? So how should I get this out of the box? Because it's awful huge.
Well, as with anything, you can actually pull out their whole getting started package, and they have lots of instructions about the proper way to pull all this out. And in case you haven't guessed, I've probably done more of these than I probably should have.
Yeah, you probably have.
So I can help you kind of get the stuff out really quick, and then we'll work on assembly
cool.
for this.
Cool.
Because I don't think Hak5 is more of a, unboxing show. It's more of a how-to show.
It definitely is, yeah. So people are interested in the build process. So let's go ahead and get this out.
We'll get everything out of this.
Oh,
it's nearly finished.
It's put together for me. This is very different from what I'm used to. With the printer bot, the kit, I had to do everything from taking all these different components and screwing them in together, and then I had to do the calibration, like everything. So it looks like most of my job is already done here.
By far.
That's
good.
All
we're going to have to do is attach the table or the y-axis on this.
Really?
Yeah, and that's it. So it's pretty simple.
Cool. All right. So I guess we need to take off the foam.
Well, you want to lay it on its side before you do all of that, because we're going to slide the y-axis out because they store it inside here just for shipping reasons.
Okay, good to know.
Now, one nice thing about these is that you didn't notice their printers and most of the components on it are actually 3D printed.
Oh, really?
So,
well, obviously not the piece right here.
Not the metal piece.
Or metal.
But if you look inside here, you'll see like these green pieces are all 3D printed over here, which is pretty awesome. So you'll get the materials like over here. You'll see there's some green pieces here. this entire gantry here is all 3D printed parts as well.
Wow.
And they actually 3D print all of these in their factory on other Lulzbot machines.
For real?
Which is kind of fun. So it's
That's
very
funny.
self-replicating.
That's hilarious. And these little yellow pieces, these look like they're 3D printed as well.
They're all 3D printed
Okay.
in Lulzbot green.
Beautiful.
They have their own little green, which I love.
It makes sense.
And
Cool.
then a bunch of parts on even this bed here. That's 3D printed, that's 3D printed. All the motor mounts are 3D printed.
Wow.
So, and all of those parts are all 3D printed.
That's so interesting.
So,
Okay,
and
cool.
for a professional company to actually 3D print their parts, I think is fascinating because it allows them to do lots of revisions really fast.
Good point.
So you can get a TAS 6. If you had a TAS 6 from a year ago,
Yeah.
there's some changes to it that they've made since then, but they still get to call it a TAS 6.
So, and because Lulzbot does the whole open source thing, like if something breaks and you don't have time to like reorder a part or anything like that, you could 3D print it.
You can 3D print it. In fact, you can just go download all the parts from them.
That's so cool.
And if you think you can do a better job designing it, you can go download it, change the files, and make your own.
Might as well.
And there's
Yay,
a lot of
fun
people that do.
times. Oh, I'm sure. It's the whole maker community.
Yes, it is, very much.
Okay, so what's next?
All right, well, you got to put this in here.
Okay.
And what you want to do is have the motor towards the back.
And there's the
And
motor.
we're going to remove these 4 little screws here.
You just set it in between the bolts?
Yep.
Oh, okay. That was easy.
And if you push that all the way forward, all we're doing is lining up those bolt holes here with this little bolt receiver.
Oh, okay.
And we'll just tighten that down.
That's super easy.
And yeah, we're doing pretty good so far. I mean, we're about halfway done already with this. How long did it take you on that one build you did?
Probably 6 hours, I want to say.
And that's actually a pretty decent amount of time to spend on a build anyway. That's actually pretty good.
Yeah.
I've known people have taken a lot more for that.
And I think it was mostly just because like I read the directions before I got into it.
Oh, that's crazy talk.
I know. RTFM, guys. RTFM. Okay.
So the next thing is that we have a few things we have to attach because the bed was here.
Oh, right.
So this motor, of course, we have to attach that. And there's only one cable for it, and there's only one direction for
I'm
it.
going to guess it's this one.
Yeah.
Right here. Okay.
So we'll plug that into that
needs to go
motor.
in. Oh, I see it right there.
Now the next one is that we have the heat bed here.
Right.
Now one of the things your printer bot didn't have, this one has, is actually auto bed leveling. So it will use these 4 nuts on here, or these 4 washers on here to set its level.
Wow.
And this is the whole heated bed. Its build volume is 280 by 280 by 250.
That's pretty big.
But there's a little secret because since they have these little corners here, they couldn't actually go all the way out to the limit. But if you go into the software and you change your settings to 293 by 293 by 250,
Oh.
as long as you aren't trying to go all the way to the corner, it'll still work.
A little hack for you.
Little hack for you.
Nice. Okay. So
These-
where does? Oh, you got all of them. Okay.
And that is all the connections for the bed.
So 3. Looks like 1, 2, 3 different connections.
So
Okay.
you got one for the power, you got one for the thermistor, which
Okay.
is what measures the temperature for the bed, and then you
Right.
have one for all the switches and buttons and contacts.
Ah, okay.
And if you look over here, you'll see all those connections. And then
Great.
all we're going to do for this very complicated rigging is we're going to just push this up into this 3D printed part, which is designed to snap it.
Oh, no way.
And now it's done.
Well, that's easy. Look at that.
Some
Okay,
people
cool.
might put a zip tie through, so they even put little holes to do a zip tie, but I find there's not even an issue to worry about there.
Yeah, you don't have to worry about it. Cool. Okay.
So we got everything done. We have the Y going, we have the X axis, all the directions of the printer going. The
Okay.
only thing left to do is install the extruder on this, and then we
yes.
are done.
We do need an extruder.
So in those boxes there, one's going to have the extruder, and I believe it is box 2.
Okay, so box 1 has toolkit, power cable, USB SD card, blah, blah, blah.
All the accessories, as it were.
The accessories. And this one is just the Lulzbot TAS single extruder tool head. Cool. Okay. So the extruder is where your filament comes out of. That's my very technical definition of an extruder.
Yeah, and depending on how you talk to it, the extruder is actually kind of a huge kind of conglomerate of parts.
Wow.
So you have the hot end, which is, actually I'll tell you what, if you get the GoPro here, you have the hot end, which is usually going to be this whole assembly, which is the kind of metal collar, it's got fins on it, then you
Right.
actually have the hot end here, and then you have the nozzle.
Okay.
And then there's a thermistor in there that measures the temperature for everything.
Yeah.
And then what you have is you have part cooling fans. This is when you're printing with PLA or softer materials.
There's fans on it?
There's the fans just for doing that.
Cool.
This is your heater, your extruder cooler, which this is always on. This is what keeps the extruder cool while it's printing.
Okay.
And then this whole assembly up here.
That was 3D printed too.
All of this was 3D printed.
Wow. And
it's actually based off of a Wade's extruders, what they call this particular style, which is a giant herringbone gear here.
Oh, that's gorgeous.
Which drives everything and gives you a lot of torque when you do your 3D prints.
Okay.
And
yeah, I remember these little parts. Okay,
all the little filaments and stuff.
Yep.
But here's a neat thing that I like about this is that every extruder needs to get calibrated to know the exact steps for it.
Right.
And when you get the extruder from Lulzbot, they actually write on the back of it how many E steps you need to have for that particular extruder.
That's so cool.
So it's very finely calibrated.
Yeah.
And then
that's quite a personal touch.
And with a lot of 3D printers, you can imagine all those components require a lot of wiring.
Right.
They make it so it's just one wire set to plug everything up.
Thank you, Lulzbot, for doing that. Because every single little one of those pins, when you have to plug those in, I hate that.
And you get the order wrong and everything like that.
Yeah,
it's
every
insane. So what we'll do is that in their actual extra box of goodies,
oh, look at that!
They throw a cute little tool bag here, which I need an Allen wrench from. So you get the Lulzbot Allen wrenches and all the tools you need to run everything. They get you up and going and ready to go.
That's really nice.
They even brand their Allen wrenches, I know. I love that. So it's
great.
A little overkill. And what we're going to do here is we're going to remove just this one bolt on the front. This one bolt is what holds the whole extruder head in.
Okay.
And we'll take that out. And now, the complicated process of dropping the extruder on is they actually have a V-slot groove on the front here. And you literally just drop it into that.
That's it.
And put the bolt on.
Put the bolt back on and it's good to go?
Yep.
Wow.
Now, an interesting thing that they do, which I think is really kind of cool, is that they have different types of extruders you can drop on for this.
Okay.
So you need a different extruder for, let's say, flexible filaments. And my personal favorite extruder that they make is called the Moore-struder, M-O-A-R.
Okay.
And it's got a really big nozzle and prints really big prints really fast, very low resolution.
Oh, right.
So a print that might take 60 hours with this type of extruder will take about 6 hours with that extruder.
Dang, that's a big difference.
But it won't have as good of a resolution. But if you like the layer lines and you like the aesthetics of it,
so what do you need to do if you need to replace it with that other nozzle?
Well, you literally just pull out that one bolt.
And that's it?
Drop in that whole assembly that they make for this, and then plug in the one cable, and you're done.
Okay.
So they take care of it. They even make a dual extruder in for this as well.
You kids are so lucky in this day and age with your 3D printers.
You don't have to put together those wood parts and manually level everything.
Like I had to.
You know. But
if you're ever wondering why I haven't touched a 3D printer in like 4 to 5 years.
That's why?
That's why. I thought that they were still like that. And I was like, oh, it's so complicated. But gosh, this is way easier.
They've oversimplified stuff, which I love. Now, they even have a spool holder on the side to hold your filament and all that cute stuff.
And it's nice and sturdy. That's good.
And you can even do extra accessories, like they have this.
What is that?
This is pretty simple. What this is it snaps on here. And when you do your filament, it keeps your filament from rubbing against the machine because your filament will run through this tube.
How neat.
Some people refer to this accidentally as a Bowden tube. This is not a true Bowden style tube.
Oh.
A Bowden tube is when it's permanently attached here and it keeps the back pressure of the filament going into the nozzle.
Gotcha.
And that's a whole other printer.
Yep, okay, cool.
So
this is just to keep it clear of any moving parts on your...
So it doesn't get snagged or anything like that or grind or anything. It keeps the path pretty clean.
Well, that's nice.
And if I turn this all the way around for your camera here,
woo!
The back side of this has a lot of really interesting label. Actually,
Okay.
I'll turn it this way so you can see it with your camera. But they actually do the little engraving so you actually know every individual thing. And if you get their head that actually has 2 extruders on it, they have it so it's just a quick connect right there and you're done.
Nice, cool.
So they definitely over-engineered this.
Well, that's great though.
Which I love.
They're trying to make it easy for people.
And
they're trying to think of all the possibilities that you might want it for.
They want it to run right out of the box.
Okay.
And in fact, we'll get it powered on here and have you printing.
Yes.
And it won't even be an hour since you open the box.
Yeah, I'm so excited about that. Okay, cool. So now we have power cable, of course.
USB cable if we need it.
Oh.
That they actually printed on this printer to prove to you that this actually
printer.
shipped.
This one.
With a working print.
Oh, that's really cool. That's super shiny. Wow.
And that is the Lulzbot filament that they use.
It's very smooth on the bottom too. It looks like it took nothing to get it off of the heat bed.
Takes nothing to get it off the heat bed. That's because the heat bed is built out of a PEI material, which is my personal favorite material to print with right now.
Awesome, very nice.
What I like about the Hak5 compared to like even a Mini is that it'll print directly from an SD, so we don't have to have a computer hooked up for this.
So they sent an SD card with it.
And so, and that actually has that file for the little octopus on it.
Cool, okay.
And that's how you prove that it's all working and everything's good.
So once we have this up and running, we can just plug this in and test it with the same octopus printing.
Exactly.
That's
and then
great.
after that, then you launch your software and figure out how you want to print the next item you want to print and so on and so forth.
That's definitely useful for problem solving because you know immediately that your printer is set up correctly, so you don't have to wait until your software is ready on your computer to find out if something's wrong.
Exactly.
That's great. Great thinking, Lulzbot.
So that's a great thing. All righty.
Next.
Next, we got to plug it in, and we'll turn it on here.
All right.
And give it a second to power up. And it's got its own screen.
Cool. Marlin.
Ready to go.
So it's running Marlin on there.
It's running Marlin, which is of course completely open source in the same tradition.
We'll be learning more about Marlin very soon.
So now what we'll do is we'll just plug our little SD card right in.
Okay.
And for now, what we'll do is we'll actually take the screen here, and we're going to go down to temperature, and we'll bring the nozzle up to temperature so we can remove the old filaments. And for the start, we're going to bring this up to about 205. That's a good start temperature, 205 degrees.
205, okay.
That is what I kind of tell everyone, start with PLA, and that's the good temperature.
Cool.
And we'll get right around 205. 206 is close enough.
Sounds good to me.
And now, if I go all the way back out, you'll see it's sitting at 206, and we're just waiting for it to warm up here.
Yeah.
And that'll take a little minute.
Okay.
We'll pull the old filament out, put new filament in, and then we'll hit print.
Sweet. Okay.
By the way, in case you didn't notice, the reason why it has old filament in there, still left in the nozzle,
right here,
is because that's the filament they actually use to print that octopus with.
Ah.
So they leave it in there to prove that this is what they actually printed with.
It's already been used.
It's been used.
Great.
And it all works.
Okay, so now that it's at temperature, I guess we should pull out this old extruder filament.
The old filament. So we'll just kind of like take that off temporarily. And with the extruder, it's just literally pop it up and it falls apart.
Right.
And now we'll just pull out the old filament.
Cool. That was very similar to what I used to have to do.
And it's pretty easy.
Nothing has changed there.
And now what we'll do, you'll notice, by the way, this filament here is actually pretty thick compared to probably what you were using then.
Yeah.
That's because it's a 2.85 millimeter filament versus a 1.75.
Okay.
In the industry, there's a lot of differences, but like the higher end manufacturers, most of them are using 2.85 still.
Okay, good to know.
And all we're going to do is just loosely throw it up the tube here because it's a very short amount.
Right.
So it doesn't have to be overly pretty.
Okay.
Let me just push it through the tube until it comes out.
Yay!
And then what we'll do here is we're just going to, if you look down the little hole here, there's a little hole that you got to feed the filament through, and it sits next to the gear. And we'll sit there, and I'll push that, and if you look down here underneath it, you'll actually see a little bit of plastic start to come out.
There it is.
And so I know that's good. And now I'll pinch the top back, or close the top back up.
Okay.
So now it's all closed and back, and we got new filament loaded.
Perfect. Wow.
I'll go in there and grab my fingers and pull that off. Don't touch that with your fingers because it's hot.
Yeah, it's very hot.
Now you'll notice we haven't done any calibration or anything to this printer.
No, we haven't. We haven't even sprayed this with hairspray yet.
That's right. That's because this is all PEI surface, which we don't have to worry about that with.
What?
So
that's so great.
PEI is kind of their is definitely something that they love putting on their printers, and I love it too. It's one of my favorite print surfaces, and doesn't require any sort of treatment for PLA. Some of the other materials you might have to put something on it, but for most normal printing, you don't even have to treat it. You just need to keep it really clean.
Wow. Okay. So just wipe it down now and then?
Wipe it down. If you get your fingerprints on it, wipe it down because your fingerprint oil is enough to actually dirty it up. So we put the little card in there, and I'll make you hit go on the print on this. So.
Okay.
And what you'll notice down there is there's a print from SD at the very bottom.
Yeah.
You click on that.
Okay.
And then you'll see all your little test prints that they include with it.
Oh, software, sample prints. So I go into sample prints.
That's correct.
Okay.
And then you can go down to the novelty, which is always a fun one.
Novelties.
And
mustache ring.
Yeah, you can print out a mustache
Fish
ring if
fossil.
you want.
And it's moving.
Now, you'll notice at the end of it, they actually said engine as their format of choice.
Yes.
Which should be close enough for us to get this print out of. We also have a spool of engine as well.
Okay.
But that should be enough to get us started in this case.
I'm so excited.
But it's going to take a minute here. It's going to warm up.
Yeah.
And on the screen, it's telling you the temperatures and everything. It's going to get the bed up to about 85 degrees.
Okay.
That's engine's temperature. Engine likes a little bit hotter.
Okay.
We're actually going to do a whole episode on different materials and how hot to get stuff and things like that.
Well, it's already heating up.
And it's a 24-volt bed.
Okay.
They're one of the few printer companies that actually do 24 volts for their entire system.
Wow.
Which will help it actually heat a lot faster for everything so you don't have to wait as long.
Cool.
And once it gets up to temperature, it'll go around and actually do its own auto leveling.
Oh my gosh.
And,
that is so much easier than trying to level things with yourself.
And you'll
Your
notice
eyeballs.
on the bed here they have a bunch of switches. So there's a switch there.
Yeah.
And then there's these washers.
Yes.
So it's going to do its very first pass where it actually will come down and hit that little switch.
Oh.
And that says, okay, that's the bottom.
Okay.
It knows, I go, that's the bottom.
Okay.
And then it'll actually will come down and hit every single one of the washers on all four corners to decide.
So it knows its like axes?
Well, it's not. It's to see how level the plate is.
Okay.
Because sometimes a plate might be a little bit rocky.
Yeah.
We're on a folding table here, so it could
Right.
distort the frames ever so slightly.
Yeah.
We're talking paper thickness distortion.
Yeah.
So, and it will measure that before each print and create this kind of three-dimensional mesh of the bed.
That's so cool.
And then level before it actually prints everything.
So it does that before every single print that you do?
Exactly.
That's nice, just in case we move this, or if there's an earthquake in California, you might want to recalibrate.
Or the temperature changes in the room and it actually causes certain things to expand and contract.
That's a good point.
So there's a lot of little subtle variances that can actually cause your printer to move around.
That's great. Okay.
And interesting thing is that, we talk about open source and all that stuff. All their prints are open source, but all their components are open source as well. They're actually using a lot of open source hardware for all of this.
Yeah.
And the board inside of it's also open source. It's actually a Rambo board, which they call it Rambo. It's actually based off the Ramps board, but it's made by a company in Tennessee, the Ultimachine company, that makes that board, and it's completely open source as well.
Awesome.
And it's very popular for a lot of printer companies to use that, or high-end printer companies to use kind of a quality board.
Is that an Arduino type board?
It is an Arduino type board, and it's based off the 2560 Arduino, the Mega board.
Yes.
And most 3D printers have that, and we're actually going to talk about that in an episode. We're going to talk about the firmware they use and how simple it can be with it, and how you can build your own.
Oh, it's moving.
Now what it's doing is it's going around and it's checking all the, actually it's doing its little wipe. So it has this cute little pad here, and it's wiping off the nozzle before it starts the print.
That's what that soft pad is for.
And
I was wondering about that.
And it's to make sure it's really clean before it starts to level. And so now it's going to go touch the washer.
Dude.
It touches it once, and then it slowly goes and touches it again to get as precise as it can and know exactly where it is.
Oh my gosh.
And so now it's going to just touch it, and now it's going to move over to the next washer.
Oh wow, that was really fast.
And then it's going to sit down there, touches it fast, and then goes touches it slow again. Very slow. It goes slow so there's no bounce. So it doesn't actually over push it or go too far before it actually senses it.
Right, that makes sense.
So it does its first touch to go, I know about where I'm going. And then it goes a second touch to go, I know exactly where I'm going.
Cool.
The funny thing is, or the one thing I love is that they have in their little firmware the way that every time it hits each point on the bed, if for some reason it doesn't sense it or there's a problem, it will go back, rewipe the nozzle, and try again.
Oh, nice.
So and
That's good.
it'll do it multiple times until it finally gets it to work for you.
Oh man, I like this so much.
If there's never an issue, and it's ready to go.
That's amazing.
And now it's done its measurements. It's going to go up here, and it's going to park for a minute, and it's going to bring the nozzle up to final temp, and then start its print.
Great. All right.
So it takes a little bit of time to warm up the machine, but then after that, it's off and running.
Perfect. Okay. It always sounds like it's playing a song.
One of the there is G-code for that. In fact, I've done a few where I take the old floppy drives out of old computers.
I remember when you did that. Oh man, that was so funny too.
You know, it's a good use for those old 3.5-inch drives.
So great, I love it.
But there's people who have done it with their 3D printers because you can actually get the hum down and all that stuff.
That's so funny.
If you're feeling ambitious.
I'm not. I'm lazy.
But now it's actually printing and it's off and running. Now, if you look at it, you'll see that it's already got the good first layer. And you probably remember from your build that you probably spent a bunch of times trying.
I had strings all over the place. I had it trying to pull away from the heat bed, all sorts of things.
And that's where printers have really come. Finished printers, now when you buy them and they get shipped to you, you know, poor UPS and FedEx that throw these things like, you know, they're nothing.
Yeah.
This thing arrived on the dock, we built it out, and it's already up and printing, and we didn't do any calibration, we didn't do any extra leveling or anything like that. And that's kind of where printers have come to.
I'm kind of speechless at the fact that it's so easy nowadays. And the prices haven't changed that much.
Not really. I mean, well, back then you'd spend $2,500 and you would actually kind of get the machine you had to build and tweak and tune.
Yep, exactly.
Now you're spending $2,500 and you're getting more of a finished machine.
Yeah, it's much more plug and play now.
It's a lot more plug and play, and there's actually a lot of innovation coming relatively soon. I mean, within the next 5 years, this market's going to definitely explode with even more stuff than the auto leveling and the filament and this type of quality print that comes off of the printer.
Now, have you ever had an issue with these kind of printers where it does like end up pulling away from the heat bed or getting stringy or anything like that?
There's always issues with that, and you have to worry about, you know, sometimes you have to tell it, you know, hey, you're printing too high, you're not printing too low.
Yeah.
You don't have to overly worry about if it's like out of sync or cattywampus.
Okay. Cattywampus.
It's a great term.
Nice terminology.
There's every once in a while there's some jams. There's things that are still traditional to traditional printers in these.
Yeah.
And I've seen some printers that are trying to negate even those problems these days.
Wow.
And over the next several years, we'll see a lot more of those printers come to the market that can detect if they're being jammed or clogged, or if they're not printing at the right temperatures.
Yeah, totally.
Sample the filaments, and do even finer bed mesh leveling. Imagine, if you will, this one only did 4 points. I've seen some that can do 20, 30, 40 points on the bed and make this extremely micro leveling precision.
Dang, yo, that's cool.
You know, and we're coming along.
Yeah, no kidding. All right. Well, I'm gonna vote that we wait for this print to go ahead and finish up. And while it's working its way, why don't we throw to a sponsor?
Sounds like a plan to me.
Darren, take it away.
If you've got a great idea, you should do what Shannon and I do and head over to domain.com and register your domain. Bring it over to the internet using this super awesome discovery system that brings domains from your mind onto the web over at domain.com. They've got a quick and easy checkout process, and they've been supporting Hak5 for years. You can also tweet at them at domain.com and say, hey, thanks for hooking up the guys, and they've got a special treat just for you. You get to save 20% off at checkout over at domain.com using the super secret coupon code. It's HAK5. It spells Hak5, and it's just between you and I, all right? Don't tell anyone. Okay, you can tell people. When you think domain names, think domain.com.
Okay, we're back, and we decided to go ahead and move the 3D printer into the warehouse so that while that is running and we're doing a time-lapse video of our print, we're going to go ahead and build our enclosure, which is a whole bunch of acrylic pieces from printed solid. So let's go ahead and get started with this and enjoy.
here's what I like about my brackets. They were designed to actually keep everything together while you assemble it, because we are removing some of the actual structural bolts from it.
Okay.
But we're not removing all 4. The way the back is actually designed on this is that you leave 2 bolts alone and replace the 2 outer bolts on the printer, so that you're not actually taking the whole printer apart while you're doing
that's
it.
good. Okay, cool.
So what I do...
So that's nice that they supply those little, what are they called?
Allen wrenches?
Allen wrenches for you.
So we'll remove this bolt here.
Okay. There it goes.
And now there's a little nut that's in the T-slot behind it. And I just want to make sure that nut doesn't slide around.
Okay.
There's also a nut here that slides up and down a little bit. So if I pull that bolt out, it's going to fall all the way to the bottom and I have to adjust it.
Oh, okay.
But if you take the printed solid sticker that's included with it and pinch it in there.
Oh, nice, yes.
Pinch it in there while you're printing, or while you take that nut out, then the nut won't fall down.
That's funny.
So I'll put this in. You could also use a zip tie, but hey, you got an extra sticker for the interim.
I'm glad you supplied this sticker. That's useful.
And that will hold it in the slot.
Okay.
And so now we'll take our little bolts here, put the bolt in, put the bracket on, and that is it.
Cool.
And we'll wash, rinse, and repeat and do this for all the corners.
Okay.
So in case you didn't notice, the design of my things actually mirror the design of their corner brackets.
Yeah.
Trying to be
notice that.
aesthetically the same and not take up any more build volume than what's necessary.
That's cool.
So
They're both on?
that's all good. We can take the sticker out.
Okay.
Now, since we have the sticker here, go ahead and hand that to me, because I will tell you an interesting secret of the sticker. It fits amazingly well right here.
Oh, nice.
Almost like by design.
I'm not saying anything.
Nice.
So
Nice one, David.
the next thing is we're going to take the SD card out,
Okay.
and we're going to stand it up on this end.
Oh, God.
We take the SD card out because
I'm scared.
that's how it can get damaged.
Okay.
And now we're going to slide the side piece on.
Okay,
All
so we
right.
got this one on the side.
So now what it is that we actually can take it off for now, because I just wanted to show you how it's going to go in.
Okay.
But what we're going to do, we're going to take this piece here and put the 4 bolts in and put the 4 nuts in, but do it very loosely.
Okay.
Now, we got all 4 of them. Now we just tighten them down by hand.
Nice.
And those are nice and hand tight. Now we take the printer, set it back up.
Okay.
We can put our little spool holder out to the side,
I'll take that.
put that on there. And actually, before you put that on, let's put the lid on. I include 2 lids,
Okay.
and if you're using the standard side one, you're going to have to put it all the way through. And normally you would do this without filament on it,
Okay.
but since I have filament,
Oh, that's easy. Wow, it fits perfectly.
the reason why it fits perfectly is because since Lulzbot publishes all their design files, I was able to get all the contours directly from their design files.
That's great. How handy.
And then this one sits in the same spot but has room to leave these rails exposed, because there's a
Yeah.
lot of users that like to mount top-mounted spool holders.
Cool. Okay.
That's all there is to it.
Okay.
And now that's 100% done.
So now all you had to do was take the front piece and the mirroring back piece and set them on top of the 2 bullets right here.
Little mounts, the nubs.
Do you have to screw anything down, or it's
No.
it's done?
It's designed to be easily lifted off, because if you need to go work on the machine,
Right.
I'll come in here and just be like, you know what, I need to come in here, pull that off.
Ah,
And now I can pull my
cool.
prints off, I can get in there
That's
and
it.
tune.
Cool. Okay.
And it's because I didn't think doors were a good way to go with this, because
Yeah.
if I put a door here, you're reaching in there and it's
Yeah.
not very comfortable.
And you have more chance of damaging your
Enclosure
thing
itself.
here. Yeah, that's a great point.
So this just literally lifts on and off and makes it so you can get access to it
Cool.
and get to whatever you need to work on.
Nicely done. I love it. Okay, so now that we have everything done, I do have a curious question for you.
Okay.
When I built my first printer, the reason why I was thinking about having an enclosure was just to like dissipate heat correctly. Is that the right reason?
That's one of the reasons, but it really depends on the material you're working with.
Okay.
Most of the time, like materials that are PLA based or true PLA,
Yeah.
which is what the most common filament is out there, you don't really need an enclosure for it.
Okay.
The only time a PLA person might really want an enclosure is if they have cats.
Oh yeah, that's a good point. I have 2 cats at home.
So you don't want them playing with the printer or getting stuck in there, or you have
Yeah.
little toddlers and things like that.
That's a good point.
If you're working with more exotic filaments, you definitely should consider an enclosure.
Okay.
And it doesn't have to be fancy. A lot of people think it needs to be these heated build chambers and all of that.
Yeah.
I'll be honest with you, I love my enclosures. I think they're aesthetically pleasing. We sell them, we love them, they're great. But a cardboard box works just as well. So if you got
Well,
a
the
big
nice
enough
thing about
cardboard
this though
box,
is you can look through it and make sure that your print is going well.
it looks good and it works good,
Yeah.
and cardboard burns a lot easier.
Oh, that's a good point.
So these enclosures and all of our designs that we work on, their secret is that we keep all of the electronics outside of the enclosure.
Right,
So they
yeah.
don't, electronics get really worn out if they're exposed to heat.
Yeah.
This keeps them all the electronics outside the build volume.
Smart. And you're an engineer, so I'm not surprised.
Electrical, so that's a big difference for us, and
Cool.
that's why it's such a complicated design. Is
Very cool.
I try to keep as much outside as possible. The holes are intentional, by the way. All the little
Yeah.
the holes and the sizes, it's intentionally to let enough heat out of there that it's not going to, no matter what temperature you run it at, none of your parts are going to melt. Remember, the 3D printer is built out of plastic parts.
Yeah, yeah.
So it's designed to literally leak out extra heat.
That's a great point. And you are offering a coupon code for people too on the website, right?
Yes, we're offering a coupon code for all of our premium filaments, 10%
Nice.
off everything.
Cool.
If they haven't guessed yet, it's Hak5.
Oh, no way.
So on checkout,
Just
go
on
ahead
the
and enter
checkout?
it. Yep.
Nice. Okay, that's easy peasy. Well, thank you for that. I know you didn't have to do that for our viewers or anything, so really appreciate it.
My pleasure. You know, I'm a fanboy of yours.
I'm a fanboy of yours.
Ah, thank you.
I'm pretty sure I watched you on, what was it, Attack of the Show?
Pack of the
When I
show.
was in high school. I'm pretty sure I did. My memory is a little foggy of that time, but pretty sure I did. Those G4 days.
Ah, yes.
So we're gonna go ahead and end it here, but we're gonna have David back in a couple of episodes, and we're gonna do a review with the Lulzbot guys to talk more about Lulzbot's open source platform for their business model, which is super interesting. And I can't wait to learn more about all the materials that go into 3D printing, because it's really, really fascinating to me. And I think I'm kind of behind the times on it, but I'm glad I'm finally learning all the components the way I should have the first time.
We'll get you involved in 3D printing again.
I really appreciate it. I'm so excited. So if you want to learn more, you can email us feedback@hak5.org. Don't forget to check out hakshop.com where you can support us directly. We really appreciate it, and that's where you can check out all of our different products. And it just so happens a lot of people have made 3D printed cases for our products as well, which is super cool. And you can also check out hak5.org for all the things that we are doing. I'm going to be having a meetup. If I haven't done it already, it's in Tokyo, November 18th. I think this might be coming out after that, but if you were there, it was nice to meet you. So that's about it. Thank you so much, David, for joining us. Where can people find you again?
Printedsolid.com.
Are you on Twitter or anything?
Oh, we're on Twitter as well. We're on at Printed Solid on Twitter. Okay. We're also on Facebook and Instagram and all the other fun places.
Perfect.
We're very social.
So you can find them there, and you can find all of us over at Hak5. Thank you so much. Trust your technolist. Darren, can you focus cameras? And 3, 2, how to build a... We're gonna get the enclosure on.